Hello everyone, welcome back to my channel. So for this video, I will mention the piecewise function. So you are not really required to learn this stuff in PreCalculus 11, but you are required to learn this in calculus courses. So I highly recommend you guys watch this video before proceed watching next video. So what is the definition of piecewise function? So basically, a single function is made of two or more different functions. So in the first case, we have x and negative x, two different functions made up of one single function. In the second scenario, I have x plus 3 and negative x plus 2 made up of one single function. So these are all the piecewise function. So basically, what's the problem when we put two different functions in the same graph? So you notice that when I apply the vertical line test, the vertical line will hit the graph at least twice. So apparently this is not a function. So because of that, I cannot say that this is a piecewise function. But actually what we could do is to restrict a domain for each component. I can restrict a domain for x, and I can restrict the domain for negative x. So this is the idea of the piecewise function. So basically, if I want to make these two piecewise functions fall into function category, I need to include this little information, x greater or equal to 0, x less than 0. So basically, if I include this information, I'm pretty sure that I make these two functions fall into function category. Okay, so let's investigate what the graph looks like for these two piecewise functions. So I'm not going to show you this function yet. I'm first going to show you this function. So basically, I want to show you the graph for this function. So let's see. So before graphing this type of function, so let's investigate what's the meaning of this piecewise function. So we know that y equals two different functions, y equals to x plus 3. So given that x is greater or equal to 2, y equals negative x plus 2, given that x is less than 2. So I'm going to first graph the first piece of function, x plus 3. When x is greater or equal to 2. So where should I start? So I should start at x equals 2. So I pinpoint where x equals 2 around at this location. So I need to plug in x equals to 2 into this function. So when x equals to 2, y equals to 2 plus 3, so which equals to 5. So 2, 5 is my first point of this function. So I assume that this is my first point. And I know that this is a positive slope because the slope equals to 1. So I just need to raise it and graph something like this. And I finish up the first piece information. And the second piece, I have y equals negative x plus 2. So given that x is less than 2, so I should start at x equals to 2. I need to plug in x equals to 2 into this function. Negative 2 plus 2, so give me 0. So when x equals to 2, y equals to 0, so at this location. But I'm not going to draw the point here, I'm going to draw the circle here. So the reason why I draw the circle here because x equals to 2 is not equals to 0, but instead it's equals to 5. So I just need to draw a circle, which means that when x equals to 2, it's not equal to 0. So basically, I need to graph the left-hand portion. So basically, negative x plus 2, we have a negative slope here, so which means that you undergo this direction. But I just need to draw the left-hand portion of the function, and this is what the function looks like as a whole. So we have the whole piecewise function showing you in the right-hand image. So next, I want to investigate if the right image here is a function or not. So basically, I can use the vertical line test to do a test. I'm placing a vertical line around this position. So when I place the vertical line at this position, it just hit one position of my function, right? So what happens if I move the vertical line at x equals to 2? So you may notice that it hit two positions and it's not a function, but pay attention to that. At this location, we have no value here. It's an open circle, we don't have value here. So that's why it only hit one position, this position. So I can say that this right-hand function falls into function category because it only hit one location of the red curve. So basically this function looks like it breaks out at x equals to 2. So this is where the point of discontinuity but you will learn this more in calculus course, so I don't want to spend a lot of time here. So thank you for watching.